Hello students, welcome back to my channel. So in this class we will discuss a very important topic, covalent bond. Already in last class we learned ionic bond. Okay, so what is the meaning of covalent bond and how does it form? Covalent bond is formed by sharing of electrons. It is formed by sharing of electrons. Sharing of electrons between two non-metals. Two non-metals to form a molecule is called covalent covalent bond. So here this covalent bond is formed between only non-metals. Understand? Okay, here in the objective purpose they will ask identify the nature of the compound in the following. Means so they will give compound like for example H2O is there. H2O is the one of the chemical compound. So what is the nature of this compound? They will ask. Means is this ionic or coordinate covalent bond or a covalent bond? Like that they will ask. Means here first we have to identify the what type of atoms are participated in that compound. Okay, means if metal and non-metals are present in that compound, that is ionic. If non-metals are there, so that is obviously covalent molecule. So here in the covalent compound, it is again two types. They are non-polar covalent bond and polar covalent bond. Non-polar covalent bond and a polar covalent bond. Okay, in last class we learned that is the word electrovalency. Electrovalency, covalency both are same. Means both are type of valency. But electrovalency term belongs to ionic compounds. Already we discussed in last class. Okay, now covalency. Covalency means the number of bond pair of electrons. Number of bond pair of electrons. The number of bond pair or shared pair of electrons. Shared pair of electrons is called covalency. Understand? Covalent bond means the bond which is formed by the sharing of electrons between two non-metals is called covalent bond. Covalency means the number of bond pair or shared pair of electrons. Understand? Okay, next how many types are there? Two types. Non-polar covalent bond and polar covalent bond. Okay, here this covalent bond is classified into two types based on the electronegativity difference. Understand? Okay, based on the electronegativity difference. Depends upon electronegativity difference. Delta means difference. En means electronegativity, short form. Okay, so depends upon electronegativity difference. This covalent bond is classified into two types. First one, non-polar covalent bond. Non-polar covalent bond is formed between similar atoms having same electronegativity. Okay, there is no electronegativity difference. Electronegativity, if same kind of atoms are bonded together, both are having same electronegativity, means electronegativity difference is zero. So here that is almost here electronegativity difference is okay. In this table I will give clearly. Okay, here now generally non-polar covalent molecules are formed by combining of same kind of atoms. Understand? So that atoms are having same electronegativity. Understand? So here example H2, N2, O2, okay, and halogens X2, P4, S8, etc. H2 molecule, N2 molecule, O2 molecule, X2 molecule, P4 molecule, and S8. These are the these are called homoatomic molecules. Homoatomic molecule means made up of same kind of atoms. Okay, here H2 is H2 molecule is formed by sharing of electrons. Okay, we know that hydrogen contains one unpaired electron. So two hydrogen atoms contribute two electrons separately. So then one pair is placed in between two hydrogen atoms. Two hydrogen atoms. So in this, how many bond pairs are there? BP means bond pair or shared pair of electrons. So one BP. Okay, bond pair of electrons are one. So means the covalency of hydrogen is a 1. Okay, next to N2. N2. Each nitrogen contains 3 unpaired electrons. We know that 3 unpaired electrons means that each nitrogen contributes 3 electrons. So 2 nitrogens are there. Totally 6 electrons are placed in between these two nitrogen atoms. So how many pairs are there? 1, 2, 3 pairs are there. So that is bond pairs are 3. So here at each nitrogen, one lone pair is there. At each nitrogen, how many lone pairs are there? One lone pair. So LP means lone pair. Lone pairs how many here? Two lone pairs. So totally, how many electron pairs are there? 5. Electron pairs is equal to sum of the bond pairs and lone pairs. In the exam, they will ask how many number of lone pairs, how many number of bond pairs, how many number of electron pairs in the given molecule. They will ask like that. Understand? So it is also very important. Next, come to the O2 molecule. Oxygen atom contains two unpaired electrons, two lone pair of electrons are there. So only unpaired electrons will be participated in the covalent bond. Understand? So here oxygen, okay, each oxygen contains two unpaired electrons. Means each oxygen contributes two unpaired electrons. Here two, here two. Okay, so and each oxygen contains how many lone pairs? Two lone pairs. Two lone pairs. Already we discussed in last class. Okay, so then bond pairs how many? Bond pairs means the electron pairs placed in between these two atoms. So one, two pairs are there. Okay, next lone pairs how many? One, two, three, four. At each oxygen, two are there. So total electron pairs how many? 4 plus 2, 6. 4 plus 2, 6. Next come to X2. X2 means halogens. X2 means what? Halogens. These are halogens. So what are the halogens? Fluorine, chlorine, bromine, iodine, astatine. Understand? So one example I will take fluorine, F2. F2 I am taking F2. So fluorine. Each fluorine contains one unpaired electron. So means that fluorine contributes only one electron. So two fluorines have contributed two electrons separately. Okay, like this one. So one pair is there. BP is 2. So what about lone pairs? At each fluorine, at each halogen, 3 lone pairs are there. 3 lone pairs. 1, 2, 3. Here also same. 1, 2, 3. So that is a lone pairs how many? 1, 2, 3, 1, 2, 3. 3 plus 3, 6. So totally electron pairs 2 plus 6, 8. Understand? Okay, like that P4S8. So these all are homoatomic molecules. Homoatomic molecules means made up of atoms of same element. So these are also called molecule of elements. Okay, next molecule of compound means that is heteroatomic molecules. They are also covalent molecules made up of different atoms of different elements. Okay, second one, polar covalent bond. This polar covalent bond is formed by formed by or formed between or formed by uh, dissimilar electronegative atoms. Dissimilar dissimilar electronegative atoms formed by dissimilar electronegative atoms. Understand? Having different electronegativity. Okay, so here these are made up of made up of different atoms. Understand? So here example, take a CH4, NH3, H2O, HF, methane, ammonia, water, and hydrogen fluoride. Okay, first I am taking methane. Okay, here carbon contains 4 unpaired electrons. So this carbon contributes 4 unpaired electrons to the 4 hydrogens separately. 4 hydrogens, 1, 2, 3, 4. 4 hydrogens. Okay, 1 electron is contributed by hydrogen, 1 electron contributed by carbon to form 1 bond pair here. So like that here 4 bond pairs are formed. 4 bond pairs are formed. Bond pairs how many here? 4. Lone pairs how many? 0. So total electron pairs are 4. Understand? Okay, so like that, come to the remaining molecules. Nitrogen is the central atom in this. So nitrogen contains 3 unpaired electrons. So it contributes 3 unpaired electrons. 1, 2, 3. And here 3 hydrogens. Each hydrogen contributes 1 unpaired electron. 1 electron like this. So and nitrogen contains 1 lone pair also. So here in this how many bond pairs? How many bond pairs? 1, 2, 3. How many lone pairs? At nitrogen 1. So totally electron pairs 4. Next come to water. Come to the water. So in this water oxygen is central atom. So oxygen contains 2 lone pairs and 2 unpaired electrons. Only unpaired electrons will be participated in the covalent bond. So each oxygen contributes here. Here oxygen contributes totally 2 electrons, but here for each hydrogen 1 electron is contributed by the oxygen. Here 1, here 1, and hydrogen contributes 1 electron. Understand? Okay, so now tell me how many bond pairs here? 1, 2. How many lone pairs here? Also 2. So total electron pairs 4. Next come to the HF, hydrogen fluoride. In this hydrogen is overlapping with, or hydrogen and fluorine both are sharing their electrons. Here hydrogen, here fluorine. So here both are having same number of unpaired electrons. So hydrogen will give 1 and fluorine also will give 1. But here at fluorine 3 lone pairs are there. 1, 2, 3 lone pairs. So totally now tell me BP is equal to 1, LP is equal to 3. So totally EP electron pairs 1 plus 3, 4. So this is about a polar covalent bond. Understand? Covalent bond is of two types, that is non-polar covalent bond and polar covalent bond. So and these are the examples. Okay, here next come to the nature of chemical bond. In the exam they will ask identify the nature of the compound, nature of the bond in the given molecules. Like that they will ask. Okay, means that depends on the electronegativity difference. Electronegativity difference. So that is standard value is 1.7. 1.7. If if electronegativity difference is greater than 1.7, greater than 1.7, that is nature of chemical bond. Nature of chemical bond is that is ionic. Ionic. Ionic bond. Okay. Next, if less than 1.7, that is a covalent. In this, we have two types of covalent compounds are there, na? That is a non-polar, polar. First one here, non-polar covalent compounds or polar bond. Non-polar covalent bond. Non-polar covalent bond. Here, that is, its difference is actually less than 0.4. Less than 0.4. Electronegative difference is 0 less than 0.4. And for polar covalent bond, its electronegative difference is between 0.4 to 1.7. Electronic difference is 0.4 to 1.7. Understand? Clear? So next, if is equal to 1.7, if electronegativity difference is equal to 1.7, here that is 50% ionic and 50% covalent. 50% ionic and 50% covalent. Okay, here examples now we'll see. Sodium chloride. Sodium chloride is there. Sodium chloride. Difference in electronegativity of okay, so that is modulus of electronegativity of higher element minus lower element, like that. Okay, here chlorine electronegativity is a, we know that 3. Okay, so that is a electronegativity of chlorine minus electronegativity of sodium. That is chlorine is 3 and sodium is a 0.9. So that is a how much? 2.1. 2.1 means it is greater than 1.7. Greater than 1.7. Understand? Okay, next less than 1.7, take a beryllium chloride. Beryllium chloride. Beryllium and chlorine. Here, whenever we see here, beryllium is a metal, chlorine is a non-metal. Okay, so then we will get clarity. Means some of the students are putting option. So beryllium is a metal, chlorine is a non-metal. So the combination of metal and non-metal is a called ionic bond. Okay, but here that is having a covalent in nature. So that is the, now we will see beryllium chloride. Okay, so here electronegativity of chlorine minus electronegativity of beryllium. So electronegativity chlorine is a 3 minus electronegativity of beryllium is a, that is 1.5. So here we will get 1.5. So it is less than 1.7. Less than 1.7. So like that, if is there any compound which is in that electronegative difference is equal? So mention in the comment section. Understand? Okay, if you get any doubt in this class, you should mention in the comment section. Okay, and we will discuss remaining topics in next class. I hope you understood. Thank you.